Hello students, today our topic is concavity and second derivative test. I already have made many videos about on this topic, but here I am going to solve one particular question so that your doubts can be clear. So our success criteria here is to find the points of inflection using the second derivative test and discuss the concavity of the square root function applying the second derivative test. Let's solve a question in which we are going to find out the inflection points and the concave up and concave down intervals. So if my question is f of x equals to, for example, x and square root of 9 minus x. So you can see that this function is the product of two functions in which one function carries the square root function. So in such cases, first of all, the first thing is that find out the domain of this function. Because of course, in this function, you will find some kind of discontinuity or it will start from certain points and its domain will not be all real numbers. So in order to write such kind of questions, we focus on the function which is written inside the square root and make it greater and equals to 0. Now solve for x, which means bring the 9 over to the other side. You will get negative 9, negative x greater and equals to negative 9. Now divide both sides by negative 1. And if you remember that in such cases, when we divide or multiply with the negative numbers, the sign of the inequality also flipped. So all real numbers which are less than and equals to 9 is our domain. Now let's try to take out the derivative. Now you will use the product rule because the two functions are multiplying with each other. Now break them out into two parts to make your life more easier and understand and avoid the mistakes. So your f is the first function, that is x, and the g is square root of 9 minus x. So the derivative of f is 1 because the derivative of x is 1. And now if you remember, if we have square root of u and you want to take its derivative, so it's directly 1 over 2 square root u and u prime. So apply this concept on the g. So the g prime will be 1 over 2 square root of 9 minus x and the derivative of inner function is negative 1 because the derivative of 9 is 0 and negative x will be negative 1. So you can write it as g prime equals to negative 1 times 1 gives you negative 1 over 2 square root of 9 minus x. Come to the other side to solve this question. So our question formula is f g prime plus g f prime. So the first derivative will be f, which is x, g prime, that is negative 1 over 2 square root 9 minus x, plus g, that will give you 9 minus x, and f prime is 1. I'm writing all the steps so that it would become convenient to understand each and every step. Now over, no over, because it is a normal product rule. Now after that one, what you have to do, you have to solve. And how will you solve? You will solve by making the denominators alike. But before that one, simplify. So x times negative 1 will give you negative x plus square root 9 minus x times 1 will give you 9 minus square root 9 minus x. And here you have a denominator under the negative x is 2 over 9 minus x. Now make the denominators alike in order to simplify it and take the second derivative. So if you multiply and divide both terms by 2 square root 9 minus x, because we don't have 2 square root 9 minus x on the right hand side term. Now write the denominator 2 square root 9 minus x one time, and now you will have negative x plus. Now remember, if you have square root of a times square root of a, you will get a. So similarly, in our case, square root 9 minus x times square root 9 minus x will give you only 9 minus x. So first of all, we will write this 2 and then write down 9 minus x. Open the bracket. You will get minus x plus 2 9 times 18 and plus 2 times negative x will gives you negative 2 divided by 2 square root of 9 minus x. Now if you will solve, minus x minus 2x will give you minus 3x plus 18 divided by 2 square root of 9 minus x. So this is our first derivative, and now we will take our second derivative. So you will have minus 3x plus 18 over 2 square root of 9 minus x as the first derivative of the function. Now here you can apply the quotient rule, which is gf prime minus fg prime over g square. So here break it into different parts to make your life easy. Your f will be negative 3x plus 18 and your g is 2 square root of 9 minus x. So in our case, the f prime will be the derivative of negative 3x is negative 3, and here you apply again the rule square root u derivative, it is equals to 1 over 2 root u and u prime. So this 2 is multiplying, so you can use the constant multiple rule, which means that write down the 2 as it is and take the derivative of the function, which will gives you 1 over 2 square root 9 minus x, and derivative of 9 minus x is minus 1. Now if I write, this 2 will cancel by this 2. So 1 times negative 1, you will get negative 1 over 9 minus x. Now come on the left hand side and try to solve it. So now take the double derivative because we are trying to find out the second derivative. So first of all, 2 square root 9 minus x whole square, because you have the g square in the denominator as per formula. Then in the numerator you will write g. So g is 2 square root of 9 minus x. F prime, that is your negative 2, minus f, that is negative 3x plus 18, and g prime you will get negative 1 over square root 9 minus x. All the data I have taken from the left hand side. Now try to solve it using the algebraic concepts. So 2 times negative 3 will gives you negative 6 square root of 9 minus x. Now this negative 1 times negative will gives you positive, and here you will have negative 3x plus 18 on the top and all upon square root of 9 minus x, which is in the denominator over here for the second term, and then all upon, now this square is on the 2, so you will get 4, and this square on the square root 9 minus x, so you will get 9 minus. Now what you will do, you will make the denominators alike for the multi-fraction of the numerator. So multiply the first term and divide the first term with 9 minus x with the square root to make the denominators alike for the whole numerator. So you will get square root 9 minus x, and now you know the concept, we wrote it before also, that is square root a times square root a gives you only a. So you will have negative 6, and square root 9 minus x times square root 9 minus x will give us only 9 minus x, and here we will have negative 3x plus 18, and in the whole upon 4, 9 minus x. Now we are familiar with one more concept, that is a over b whole upon c gives us a over bc. So our a is here, our b is here, and this is our c. So how can we solve it? Write the a. But while you are writing the a, open the bracket also. So negative 6 times 9 give us negative 54 plus negative 6 times negative x gives us plus 6x minus 3x plus all upon b and c together. So you will write here 4, 9 minus x and square root of 9 minus x. Now, if you want to solve, you know that 9 minus x has a power 1 and square root 9 minus x, which means has a power half. So if the bases are alike, we add the powers. So half, here the power is half and here the power is 1, which will gives us power 3 by 2. It means you can write it as 4, 9 minus x to the power 3 over 2. Now solve from the top. So 6x minus 3x gives us 3x and negative 54 plus 18 gives us, I guess, 36 with the negative sign. So 3x minus 36. Now this is what? This is our second derivative. Now in the next slide, we are going to see that how can we find out the inflection points from this equation. So let's check how can we find out. Carry on. So we will have 3x minus 36 over 4, 9 minus x to the power 3 by 2 as the second derivative and make it equals to 0. So if we cross multiply, so the left hand side denominator will be multiplied by 0 and we will be left only with our numerator equals to 0. Solve. So 3x equals to 36. Divide both sides by the 3 and we will get x equals to. Now if you remember, our domain for the function was x less than and equals to x less than and equals to 9. So it means here 12. Now if I make a number line, so this is my 9 and here is my 12. So less than 9, it means everything which falls less than 9 will be my answer, and this 12 is not my inflection point as it doesn't fall under the domain of the function. And again to remind you, our domain was all real numbers less than and equals to 9. So here 12 is greater than 9, so it will not be my inflection point. So you just write here, not the inflection point. And now if you choose anything greater than 9, you will get the error. So now if you want to see, just have a look. Now where is my second derivative? This is my second derivative. Now take any number above 12, for example 13 or anything, write it in place of x and just check what do you get. You will get the error. Now after that one, what you have to do, you have to choose any number less than 9 and check, put it in the second derivative and check do you get the positive sign or the negative sign. So you have 30 seconds to solve and check what sign do you get, because if it is a plus sign, you will have the concave up, and if you get the negative sign, then it means that you are going to have the concave down. And after doing this, check by using the graphic calculator your answer that whatever you are writing is correct or wrong. So you have just 30 seconds to finish this thing. So what you will find that you will get a negative answer. So anything you will write before the 9, you will get a negative answer, which means you have a concave down. So what you have to do, sorry, you have to write the concave down intervals, which are from negative infinity till 9. Now 9 was included. If you remember from here, equal sign shows that it is included. So you have to write the. So that is all. And I hope that you would understand that how can we determine the derivatives, first derivative and then the second derivative for a square root function.